Hello, this is the integration by parts technique. I usually use the integration by part technique in chemical engineering mathematics courses, and I think that it is very useful to share with you guys. Usually, there are two methods that you can deal with the integration by parts. The first is conventional method, linear. So the linear method stands for the logarithmic function. So L is logarithmic function. It can be ln natural log. We don't usually say ln as ln. It's ridiculous. Normally we say ln as log or natural log or ln. That's okay. Or the logarithmic function. And I is the inverse. So it can be inverse trigonometric function. And A is algebraic function. So algebra, for instance, x squared, x, or anything else. And T stands for the trigonometric function, cosine, sine, and anything else. E, which is the exponential function. For instance, e to the power of x. And another method that I'm going to introduce is the DI method, which is quite simple. But both methods are the same, but the difference is the writing of it. Okay, so for the conventional method, we know that for the integration by parts, the formula of it is when you integration of u with respect to v. So the answer will be u times v minus the integration of v du. So this is the integration by parts formula. And when you choose it, you choose the priority from L to E. And you can see that from L to E, you will see this one is A, this one is a trigonometric function. So A comes before T. I will choose A as the differentiate term. Let's say u is x. So dv is the rest of it. dv is sine x dx. And you differentiate this, du by dx is equal to 1. And you move x to another side. And for this is v. The integration of sine is cosine dx. But when you differentiate cosine, you get minus sine. So it's negative sine, negative cosine. Alright. Now, I just remove this thing, as you know. And you can see that you just plug in the formula. So integrate x sine x dx is that it's u times v. It's u times v. So it's minus x cosine x, and minus integration of v du. Integration of v du. So it's integrate cosine x dx. And now you will get the answer, which is x cosine x. And negative is positive. So positive integration of cosine x dx is the sine x, right? So you will get the answer sine x plus c1. Let's say that it is c1 or constant. Now let's see for the DI method. So the DI method is quite similar to the conventional method. For the DI method, we will set up the table. The table for the left hand side is differentiate and the right hand side is integration. And we will set plus and minus sign at the most left hand side of the table. Now, DI method, we just use the same. But I would recommend that for the term that you will differentiate, can be differentiate until it gets 0. So when you start, you choose the same. So u dv, and you do the differentiate of this du and v. Differentiate all of it. And for the plus and minus sign, you start with plus, the next row is minus, and plus minus all over again. Now, if you want to do the integration by parts by using DI method, the simplest way is that you start by multiplying this term. So when you multiply this term, you will get u times v, as same as the formula. And now you want v du is over here, right? So you multiply all of this. Okay, so for uv it comes from this, and v du it comes from here, so it's minus v du, and you will get the answer at the end. Let me show you. For the DI method, x sin x dx, it's the same. Now let's see if I do it. If I do DI method, I will choose x in the differentiate term because I can differentiate it until it gets 0. And another one is sin x that I will choose. You differentiate x, you get 1. Differentiate it one more time, you get 0. But you integrate sin x, you will get minus cosine x. And you integrate it one more time, you will get negative sin x, and plus minus plus. Now you multiply this one, the lower one, so you will get plus x multiplied by cosine x, so it's minus x cosine x. And now you do it again, you will get plus sin x. And now at the end, don't forget to multiply this term. It's the term of v du, right? So you will get 0. And don't forget to plus c. So that's it for the integration by parts. And this trick I would recommend you when you have quite a lot of work to do with the integration by parts and you are a bit suffered with it. Okay, thank you very much.